I would like to explain about battery backup switchover function for RX8111CE. This is the agenda. I will explain in this order. What is battery backup switchover function? This function switches from the main power supply to the backup battery. Even if the power is unexpectedly turned off, the real-time clock module will detect it and automatically switch to the backup battery to continue operation. Advantage of Epson real-time clock module for battery backup switchover function are: minimal leakage current, no external diode, no diode voltage drop, longer battery life. From this section, I will explain RX8111CE battery backup switchover function in detail. In next slides, I will explain each scenario and go over the configuration as shown below. The table shows the condition mode, switch operation, and voltage detection. Light blue paint corresponds to this page, and next line is shown on the next page. The block diagram shows current flow by light blue line, switch on/off by red line, voltage detection by triangle, in case of an operation, painted it by light blue color. Timing chart shows transition of voltage at each terminal. Light blue line is transition of voltage of this page. Scenario 1. You are watching a movie with HDD recorder. Once the movie is over, HDD recorder main power goes off. Automatic switching to backup battery of the real-time clock module keeps the accurate time. Scenario 1, Case A. The condition is in case VDD more than VDET1. VDET1 is detection voltage. We call normal mode. In this case, switch 1 is on, switch 2 and 3 are off. Compare with diode or connection. Epson RDC module advantage are: automatic switching by voltage monitoring. Switch 1 on, no voltage drop of parallel diode. Switch 2 and switch 3 off, no leak from battery. Scenario 1, Case B. Main power supply is off, and in case VDD less than VDET1. We call backup mode. In this case, switch 1 is off, switch 2 and 3 are on. Compare with diode or connection. Epson RDC module advantage is: no voltage drop of parallel diode, due to switch 2 and 3 are on. Next, Scenario 2. There are times when the factory sets the time and ships the product. For example, HDD recorder. It might take 6 months to a year for a product to reach the end user. When the system power is up for the first time, with backup battery, real-time clock module can start up with an accurate time, and keep the time till the system reaches the end user. This section explains the initial operation of RX8111CE. When power is supplied first from the backup battery. Scenario 2, Case A. First, the power supply from the backup battery starts. The voltage of the VBAT will rise. Scenario 2, Case B. When the voltage of VBAT rises to a certain extent, switch 3 turns on. The voltage at VOUT, which is the internal voltage of the RDC, rises. Scenario 2, Case C. When VOUT rises further, switches 1 and 2 turn off. VDET that monitors VDD starts operating. After that, when the main power is turned on. The real-time clock module will be ready to accept commands. In this state, whether the power is supplied from the main power supply or the backup battery is determined by the voltage of the main power supply side or backup side. Scenario 3. When a secondary battery is used for backup. Rechargeable battery can be charged and stopped by comparing the main power supply and secondary battery. Scenario 3, Case A, indicates that the secondary battery is being charged from the main power supply. As advantages of RX8111CE. Since switches 1, 2, and 3 are on, there is no voltage drop across the diode connected in parallel. Therefore, efficient charging is possible. Scenario 3, Case B. The secondary battery is fully charged and the main power supply is supplying power. Switch 1 is on and switches 2 and 3 are off. As an advantage of RX8111CE, automatic switching is performed by voltage monitoring. Since switch 1 is turned on, there is no voltage drop due to the diode connected in parallel. Since switches 2 and 3 are off, there is no leak from the backup battery. Scenario 3, Case C. It is a continuation from the previous page. The main power is turned off. It shows after VDD is VDET 1 or less and automatically switching from the main power supply to the backup battery. Switch 1 is off and switches 2 and 3 are on. The advantages of RX8111CE. Switches 2 and 3 are on. There is no voltage drop of parallel diode. Efficient power can be supplied from the backup battery. Scenario 4. When using a battery as the main power supply for devices such as digital cameras, longer battery life is required. Power switching provides longer battery life compared to diode or connection. Scenario 4. When VDD decreases gradually, the battery does not shift to backup until VDD drops below VDET, and the rechargeable battery remains fully charged. Therefore, battery consumption is lower compared to diode or connection. Scenario 5. If there is a need for operation with minimum current consumption, switches can be fixed as below. Switch 1, off, switch 2, off, switch 3, fixed at on. In this case, power monitoring circuit stops and operates as a diode or circuit. Advantage: operation with minimum current consumption. Disadvantage: switch 1, switch 2 parallel diode voltage drop. Scenario 5, Case A. Switch 1 and 2 are off, switch 3 is on and fixed, no voltage monitoring is set. In the case of this page, the voltage on the VBAT side is high and power is supplied from the backup battery. Scenario 5, Case B. Similarly, switch 1 and 2 are off, switch 3 is on and fixed, voltage monitoring is not set. In the case of this page, the voltage on the main power supply side is high and power is supplied from the main power supply. Up to this point, we have given a detailed explanation of battery backup switchover function of RX8111CE. This is a comparison of Epson products that have a battery backup switchover function. There are differences in built-in parts and voltage monitoring depending on the product. When considering only this battery backup switchover function, the higher performance product goes to the left side. Various materials are available on the Epson Crystal device website. Please check it. Here is the appendix explanation. Appendix for Scenario 3. In many cases, real-time clock module and MCU main power supply is shared. If the main power suddenly shuts off while charging the secondary battery, there will be a backflow from VBAT if switch 1 is on. It will look like there is a main power supply voltage and backup battery will be drained. Switch 1 intermittent off is used to prevent backflow from the backup battery. When the main power supply is turned off, backflow from VBAT occurs. If switch 1 is on when the main power supply shuts off, main power supply may be shared with MCU, etc. It looks as the main power supply is available. Intermittent switch 1 off. It can check much precision voltage by preventing reverse current from VBAT to VDD. Switch off setting is shown in the table. You can set it not to turn off, and to turn off only for 2 milliseconds, 128 milliseconds, and 256 milliseconds per second. This turning off enables correct VDD voltage detection. In case of low impedance of VDD side, steep short switch off period, example 2 milliseconds, is recommended to judge the steep voltage dropping. In case of high impedance of VDD side, long switch 1 off period, example 256 milliseconds, is recommended to judge the slow voltage dropping. Light blue line shows actual operation. Switch 1 turns off when VDD less than VDET1. Red line shows when only switch 1 off function is used, and there is no VDET monitoring function. That's all. Thank you for your attention.